Okay, so we're doing part 2 of inverses today. This is the last lesson of this week. Again, it's a shorter week, so make sure you watch the lesson yesterday, which was part 1 of inverses. So here's part 2. So we are going to do a brief review of yesterday, just 2 problems. How do you tell if 2 functions are inverses or not? And then we are going to be given a function, find its inverse, which was, again, like yesterday, but then we'll be graphing both the original function and its inverse. I am going to be using Desmos for graphing, so that will be important for you to have. And then we're just going to make observations about graphs, because there's some important things you're supposed to know about functions and inverses when you graph them. So let's get right to the examples. So state if 2 functions are inverses. This is where you do f of g of x, and you also do g of f of x, and both of them should work out to equal x. If either one of those does not equal x, then the answer is no, and you're done. So like normal, I'll do the even, you can do the odd. So let's start with g of f of x. I could have started with f of g of x. It doesn't really matter. So I'm going to start with this function, negative 2x plus 5, and then I plug this function into it. So that is composition. What am I doing here? Negative 3 minus 4 thirds x. So plug f of x into g of x, and then simplify it and see what happens. So how can I simplify this? I'm going to distribute the negative 2. That gives me negative 6. Then negative 2 times negative 4 thirds. Negative times negative is positive. This is 2 over 1, so 2 times 4 is 8 thirds x. And then bring down the plus 5. And then negative 6 plus 5 are like terms. Those go together. It gives you negative 1 plus 8 thirds x. Now, there are no more like terms. There's no distributing, multiplying, dividing, adding, subtracting. Nothing else you can do to simplify or manipulate this expression in any way. So having exhausted every possible step, the question is, does this work out to equal x? And the answer is no, it doesn't. And since it doesn't, this is automatically a no. You do not have to do the next step, which is g of f. F of g. Since we already failed, and this is the one case where failure is good, it means you can stop working because you've got your answer. The answer is no. Okay, so just, that was something from yesterday. I don't do this a lot. I know that there are math teachers who every day you learn something new. There's also a review from the previous day. I don't use that technique or that strategy of teaching very often, but every once in a while I'll throw in something like that. Okay, find the inverse, then graph the function and its inverse. Now, in a sense, this is review, because yesterday we went over the 4-step process for finding an inverse, and we do have to do that again today. So that is review from yesterday, but then the graphing will be new. So what is this 4-step process, if you recall? Step 1, you just write it as y equals instead of f of x or g of x or whatever. Step 2, switch x and y around. So x equals 15 plus 10y over 3. Step 3, you have to isolate. Oops, I said y, but I wrote x, didn't I? Make that more clear. Okay, step 3, you have to isolate the y. To isolate y here, I'm gonna copy this down. I'm going to bring it down. Oops. Oh, come on. Duplicate. There we go. So to isolate y in this problem, first thing I want to do is cancel out that 3. And since it's being divided here, the opposite of divide is times, so I'm going to multiply both sides by 3. I get 3x equals 15 plus 10y. Next, I would subtract 15. Get 3x minus 15 equals 10y. And then last, divide by 10. And there's 2 ways you could write this answer. So you could write it y equals 3x minus 15 over 10. If you watched the video yesterday, you'll remember that there's often a lot of different ways to write an answer. So y equals 3x minus 15. You could also split it up into 3x over 10 minus 15 over 10, and then simplify that to 3/10 x minus, okay, 15 and 10 are both divisible by 5, so that's going to be 3/2. So step 4 is to rewrite your answer with the inverse notation. So this started out as g of x. Our answer is going to be g inverse of x. And so the answer could look like this, 3x minus 15 over 10, or it could look like this, 3/10 x minus 3/2. Before I get to the graphing, I'm going to go ahead and scroll down and check number 4, and I guess I got to check number 2, don't I? So, oh, that's right. I made this a really long worksheet as far as length, so they have lots of room to work. There's not a lot of problems. So anyway, 2 was a no, good. And number 4, okay, looks like they left the answer like this. All right, now we need to graph them both. Now, you should know how to graph from Algebra 1 and Algebra 2. Should not be too difficult, but I am going to start hopefully getting you used to the Desmos graphing calculator. So we need to graph both the original function and the inverse function answer that we got. And we can do this, I'm going to use y equals. I think you can type g of x if you want, but there's really no point. Okay, I hit the fraction bar first, and on top I'm going to type 15 plus 10x. Oops, apparently I'm not. 15 plus 10, come on, 10x. And then down on the bottom I need to put a 3, and I get this line. And if I tap the screen, I can find sort of the intercepts, to help me get an accurate graph. So negative 1.5 right about there. You run your finger along the graph, you'll get other points. So, sorry, I have an issue here. What is that, negative 3, negative 5-ish? Yeah, negative 3, negative 5. You get a few points on here. If you're using Notability, you can snap to a straight line. If you're using pencil and paper, you can use your driver's license or student ID to get a straight line if you want, or you can just sketch it to the best of your ability. All right, now to do the inverse, I'm going to type in y equals, hit the fraction bar first, or the divide button, sorry, hit the divide button that creates a fraction bar. 3x minus 15 on top, and then on the bottom I'm going to put a 10. And so that gives me this line. So 5, 0 is one intercept. Do you know what? Since I can, I'm going to change this to red, just like, oh, you know what? Our first line was red. All right, give me a second so I can get fancy. I'm going to change that to red, and then I'm going to make this one blue, just like on the screen. So 5, 0. That intercept is 0, negative 1.5. Where do those two lines cross each other? Oh, that's not super handy. Right about there. Let me run my finger along the graph to find another good whole number point. So it's that negative 5, negative 3. Right there. And I can adjust this a little bit. And it looks like that blue dot right there was just dumb. It wasn't even close. So there we go. Put some arrowheads on there, and that is the graph. Now I said that what we're going to make some important observations about the graph. So here it is. Do you notice where the graph intersects each other? That the x and the y values are the same. They're both negative 2.143. If the graph is curvy and it intersects itself more than once, the x and y coordinates where it intersects will always be the same. So whenever these two lines cross each other, they're always the same. Secondly, I want to graph the line y equals x. I'm going to make that, change that. There should be a way to change that to black. Now, that black line, y equals x. Y equals x is called the identity function. I'm going to write this down here. I'll write it in, no, let's use black. Y equals x is called the identity function. because every point on that line, if you see me run along there, the x and the y coordinates on every point are the same. 1.94, 1.94, what was that? 22, 33, 0, 0, -5, -5, yeah. So that's kind of an important line because that is where these two, the blue and the green, intersect each other. Like we said, those 2 points are the same. But if you can imagine that that black line is a mirror, then the blue line is a reflection of the red, or the red is a reflection of the blue. Or you can say there's line symmetry over the line y equals x. So I'm going to put it this way. G of x and G inverse of, no, that's the wrong way to say it. How do I say it? I'll put it this way. G inverse of x is a reflection of G of x. You should have done reflections in geometry, even algebra 2. G inverse of x is a reflection of G of x over the line y equals x. And that will always be the case. Every time you graph a function and its inverse, the two graphs will be reflections of each other over the line y equals x. Okay, that's going to happen again and again. I'll bring it up each time it happens. Let's do number 6. Find the inverse. Step 1, y equals the 5th root of x plus 2. That is a weird looking plus sign. Step 2, x equals the 5th root of y plus 2. Step 3, isolate x. Let me duplicate this so I have room to work on it. Okay, oops, sorry. To isolate y here, step 3, isolate y, I'm going to need to cancel out this 5th root. Do you remember from yesterday how to cancel out a root? If you said power or exponent, you are right. So to cancel out a 5th root, we need to raise this to the 5th power. This makes that cancel out. But, of course, if you do something to one side of an equation, you have to do it to the other side. So I get x to the 5th equals y plus 2. Now, is y isolated? No. Need to subtract 2 on both sides. X to the 5th minus 2 equals y. Now, is y isolated? Yes. Step 4. This was originally a h of x, so my answer is going to be h inverse of x equals x to the 5th minus 2. Let me go down and check that, number 6, to make sure I'm right. Number 6, did I just do an even problem? Or I always do even problems. Oh my gosh, I'm losing my mind, guys. There it is. Okay, good. And then look at the graphs. Now, if we draw a line diagonally right through the origin at 45 degrees, that is the y equals x line. Before I get up there, do you see how there is symmetry, or there's a reflection? The green and the blue graphs are reflections. So that's what we should be getting when we draw our graph. So let me go back to Desmos. Ooh, that's not what I want to do. I want to do that. I'll clear those out. I'll leave y equals x in the picture. So the original function y equals, now 5th root. If you hit the root button that you see, that's a square root. We don't want a square root. We want a 5th root. Over here to the right, there's a button that says FUNCS, stands for functions. It brings up a pop-up menu. Go to miscellaneous, the miscellaneous tab, and then in the middle column, more than halfway down, there's an nth root. You put a 5 there and make it a 5th root, and then under here you can type in x plus 2. And we get this graph. So now we need to try to translate that to paper. So right about there, and you know what I'm going to do? Let's do this in purple. I'll try to match what's on my screen. So purple there, -2, 0 right there. Is that point? That's kind of tough to see. So I'm just going to do my best to sketch it. I'm going to call that good enough. Okay, now let's graph the inverse. Y equals I need x to the 5th power. So hit the x button, hit the a to the b button, and type a 5 up there. Now, if I type -2, it automatically brings me down to where, well, you can just type in -2. I don't know what I'm trying to say. And it looks like this graph is in black. I don't want that to be in black. I want it to be in, how about red? There we go. Switch this to red. And what do I have here? 0, -2, 1.149. Do you notice the x-intercept in one is the y-intercept in the other? And the y-intercept in one. So these 2 points kind of go together, and those 2 points kind of go together. So what am I trying to do? Something kind of like, that's not quite the right curvature. Something kind of like this down here. And then this curves up through here. Keeps on going. And then, of course, if I were to graph the line y equals x, the diagonal line through the center, I get that. The diagonal line through the center, the black, is optional. It's not a required part of the directions. I'm just drawing it in there to help visually point out how these two graphs are reflections of each other. If that black line were a mirror, the purple would be a reflection of the red, or the red would be a reflection of the purple, however you want to say that. Okay, now I realize not everyone is a super great artist and can draw perfectly well. Just do your best to plot the points where they are, connect the dots, make it look as reasonable as you can. I'm not going to get really, brutal on grading. In fact, you grade your own work. So if your graph is as good as you can do it, and you did it on Desmos, and you know what you're doing, in your head it all makes sense, you can still give yourself a really good, fine grade on this assignment, even if your graphs are weak. I'm totally cool with that. I do want to point something out, though. Let's say you are taking a test, and you need to find the inverse of this function, and you come up with that as an answer, but you don't know if you're right. Even though you might not have to graph them on the test, you can graph them on your calculator, on Desmos, or if you have a TI calculator. And if the graphs are reflections of each other, then you know you got the right answer. If the graphs aren't reflections of each other, you know you made a mistake somewhere, and you can go back and fix it before you turn in your test. So there's a little pro tip on test taking for all you good people. Okay, let's do number 8. I already checked number 6 before we started. So find the inverse. Now, if you got this at this point, the rest is just repetition. There's nothing else new I'm going to do. Like if you think this would be a difficult one or that would be a difficult one, you might want to keep watching or skip ahead. But I'm going to do more problems. But if you're good to go, you can just go ahead and get to work. All right, y equals 2x minus 1 to the 5th. Step 2, x equals 2 y minus 1 to the 5th. Step 3 is to take step 2 and isolate the y. So what am I going to do here? Well, for starters, I need to divide the 2 over to this side. X over 2 equals y minus 1 to the 5th power. Now to cancel out a 5th power, I need to do a 5th root, and you need to do that on both sides of the equal sign. This cancels this. You get the 5th root of x over 2 equals y minus 1. Now add 1 to both sides. The 5th root of x over 2 plus 1. Notice this bar does not cover the 1. That 1 is outside of the bar. Equals y. Now there is a way to simplify this, and I absolutely do not want to get into it right now. I'm going to say even if the answer key is different, that we will stop here and call this good enough. Let me check it. I'm curious to see. Number 8. Yeah, they go through this whole process to simplify it. Do I want to do that? Not really. Excuse me. Yeah, we're going to call that good enough, and we'll just graph these. So if you're wondering, well, I got to know how to simplify it because if it ever comes up on a test, I'm going to need to be able to know how to do it. I'll make sure that something like this is not on whatever test or quiz you have to take in the near future. Okay, so y equals 2 parenthesis x minus 1 parenthesis raised to the 5th power. So what do I want to be in red here? There's an intercept. There's an intercept. And it passes through this point. So it goes kind of like that and like that. Now let me type in the answer that we just got. Y equals. Okay, do you remember how to get a 5th root? You go to Functions, hit the root button, put a 5 there. Inside here I can put the fraction bar, x on top, 2 on bottom. And then I need to move the cursor over outside of the radical and put plus 1. And now in blue, sort of a light blue, you can see this. Let's find some key points. -2, 0, 0, 1, of course 2, 2. So it goes through here and there. And then that is the answer. If you remember when I checked number 8 just a minute ago, it's the same graph, so we're good. This answer looks different, but I'm saying we're going to be okay with that. The fact that our graph is the same means we must have done it right. If you want to draw this black line in, you can. I'm going to say that you don't absolutely have to. It just gives you a little perspective, giving you that mirror image. And my line isn't even right, but there, that's a little better. Okay. Number 10. Again, we're just being repetitious at this point. Step 1, y equals 2 over x plus 2. Step 2, x equals 2 over y plus 2. Step 3, take the previous step and isolate y. You know what? I'm going to need this space. This is why I gave all that space in the first place. So how about if I just use it? All right, there we go. So how do you isolate y? Well, I'm going to teach you a shortcut. Let me do it the long way. Multiply both sides by y plus 2 as a whole quantity. Put it in parentheses like it's one complete unit by itself. That way, this y plus 2 cancels with that y plus 2, giving us a 2 over there. Now on the right, you could distribute the x, but that would actually be counterproductive. We want to isolate the y. The last thing we want to do is tangle it up by sticking an x next to it. So why would you leave that x right there? Because in the next step, you can divide by x, and you get y plus 2 equals 2 over x. Now to isolate y, you just subtract 2 on both sides, 2 over x minus 2, and there it is. And then step 4 is to use the inverse notation, which is g inverse of x equals 2 over x minus 2. So that should be our answer to number 18, or number 18? What am I talking about? Number 10? Hopefully they didn't get crazy with it. Yep, there it is. Now we need to graph both of these functions. Okay, so the original one, y equals fraction bar 2 on top and x plus 2 on the bottom. Now we get this interesting shape. There's a fun name for that. The name of that shape is a hyperbola. Doesn't that sound cool? Let me use dark green. So it's kind of in two pieces. So 0, 1, and that doesn't really help. But basically it's a curve that goes up like this and like this. And hyperbolas have what are called asymptotes. You may remember from Algebra 2, there's like an invisible line here and an invisible line here. Now let's see. -4, -1 is a point on the graph. Is there another point we can use maybe for some perspective right there? -3, -2. and the curve goes like this. Now I'm going to erase those dotted lines. Asymptote is basically like an invisible barrier that the graph never crosses, so it's kind of like a boundary line. But if we draw that in, it's going to just clutter up the diagram too much. All right, let's go ahead and graph the answer we just got. So y equals fraction bar, 2 on top, x on bottom, move the cursor over, minus 2. Now that is the purple graph. So let's see the purple graph. 1, 0. Is there any other point? What is that point right there? Oh, all right. Not very coordinated, sorry. What is that? 2, negative 1. And then it looks like the asymptote is the y-axis. And then it kind of curves out like that. Now for the other little piece here, are there any whole numbers that can help us get a good location? So what is that? Negative 2, negative 3. And negative 1, negative 4. Yep, negative 1, negative 4. And it sort of curves like this and like that. And then you can see by the black line there, which again you don't have to do, I'm doing it just as a matter of perspective. Wow, okay, it demonstrates that my graphing is off a little. I think this green graph down here, I just really didn't curve it enough, maybe, because it's supposed to go through that point. This one up here is pretty close. Yeah, that's okay. So the red and the green are, again, reflections of each other. If the black line was a mirror, the red, where I get red from, the purple and the green are reflections of each other. Purple and green, that's like Hulk. Okay. Number 12, last one. This is another rational. Or, you know what? Up here I mentioned, okay, I mentioned on step 3 how that there was a shortcut to solve it, and I did it the long way. I'm going to do the shortcut now. If you don't care, skip ahead. But here it is. Here's an optional way to show this work. I'll do red as an option. In fact, I'll change this to red. Okay. Optional method. And here it is. Put the x over 1. Now, what we have is a fraction on each side of the equal sign. This is called a proportion. Something you're allowed to do in proportions is flip them both over. Now that they're both flipped over, I can multiply both sides by 2. 2 times 1 over x is 2 over x. And then minus 2. I get 2 over x minus 2 equals y. And there you go. Same answer, just a different way of doing it. Okay. Let's look at number 12. So find the inverse. Step 1, y equals negative 2 over x plus 2. Step 2, x equals negative 2 over y plus 2. By the way, could you completely skip step 1 and just set it up like this? Yeah, I understand that you can save time and save steps if you want. All right, let's solve this. Subtract 2 on both sides. X minus 2 equals negative 2 over y. Multiply both sides by y to cancel this out. But don't distribute the y, because the next thing we're going to want to do is divide the quantity x minus 2 in order to isolate the y. Had we distributed it, we would not be able to isolate it. So there it is, negative 2 over x minus 2. Could I have done that optional method again? Yeah. Final step, what was this? H of x, so I can call this h inverse of x equals negative 2 over x minus 2. Let's go ahead and check number 12 before I draw the graph. I'd hate to get all into graphing it and find out I'm wrong. So there it is, and our graph should look kind of like that. So keep that in your short-term memory if you can. Let's type this into Desmos. First, the original. Y equals negative fraction, 2 on top, x on bottom, move the cursor over, plus 2. And I don't want that in black, I want that, let's do that in red. So, can I draw this? 1, 0, was that 2, 1-ish? Yeah, 2, 1. I get my curve like this and like this. How about the other curve? Oh my gosh, if I could be a little more coordinated. Negative 2, 3 is a point. Whoa, that took off. What is that, 1, 4? Close enough. So we get going up and curving out like that. Again, there are these asymptotes that split the graph, but you don't have to draw those. Now let's graph the inverse. Whoa, what did I do? Oh, there it is. Y equals fraction negative 2 on top, x minus 2 on bottom. Certainly don't want that in red. Let's do blue. And sketch that on there. So right there, got another point, 1, 2, curve it like this, and like this, and then the other part of the graph, 3, negative 2. So if you're not sure what I'm doing right now, you just put your finger on the graph and then move it around. So 4, negative 1, close enough. Just don't pick your finger up, leave it on the screen of your iPad and move it around. Okay, so that is the graph. Is that what it looked like? Do you remember from down below? Yeah, exactly the same. Again, I'm going to draw this black line through here just as our little mirror to show you how there is symmetry. But you don't have to do that if you don't want to. Okay, so this took a while, but it's all done. Please do the odds. Contact me through the normal means if you have questions. Other than that, have a great day.